Right guys, I'm going to show you a repair video of a 386 motherboard that I had gotten in a recent pickup haul. Normally I don't upload to YouTube about this kind of thing, mainly because my main follower base is on Twitter. However, this is probably too much for a Twitter thread, so I decided to make a little YouTube video about it. So I will interleave the repairing content with the original clips from the unboxing on Twitch and the initial tests. Enjoy this video.
Oh, this is what is
Oh.
that CPU? A chip Super 386.
Oh, this is a bargain. This is a super rare CPU.
Is it?
Yeah.
I've got something pretty special here. This is a 386 motherboard. It's an ABIT AB-FA3 with a PGA socket for the 386 and a coprocessor socket. However, this is why it's special. This CPU I'd never seen before. It's a Chips and Technology Super 386 DX with 33 megahertz. And the board is completely dead. No postcodes. Actually, that's not entirely true. Here's the clip of what it did when I first got it, and it only did it then. Afterwards, it was completely dead. Take a look.
10, 0F, 22, 25, 2C. Oh!
Oh god. Well, at least the
It's
rare
beeping.
CPU works.
It does come out of reset. And the reason for that is fairly easy to see. If we zoom in on this, you can see that there is extensive corrosion damage. Look at this crap. Oh no. So this is obviously gonna take quite a lot of DLC to get going. So what I'll do is I will desolder the keyboard connector, the power connector. The battery will be removed, of course. The RAM sockets, because there's corrosion in them, as you can see right there, for example. We'll remove these chips, of course. We'll clean them. We'll desolder this chip and this chip and this socket and this chip and this chip and this chip and this socket and this socket and this socket. And this chip. And everything below here seems to be unaffected. So sort of like everything to the left and top of my hands there. So here's just an overview of the damage. Bottom of the board. You can definitely see some of this is gonna need work. Look at that. Blech. Ah, nasty. All nasty shit. So yeah, this will be fun. Not. Yeah. Those sockets look a little bit screwed up, if you ask me. Nasty. Desoldered and cleaned all the bigger parts. Should be fairly doable. Doesn't seem to be too many broken traces. That one seems to have rotted away. But other than that, it's looking fairly good. Scraped off the solder mask on a lot of these traces here that looked fairly bad, but actually below the surface was pretty okay. Smaller components, these transistors and resistors and diodes, I will probably replace them. This, I forgot to show this. This tantalum capacitor came pre-exploded. I will probably have to replace all of these. I don't have any tantalums. Oh, there's a blown up tantalum here. It came pre-blown, guys. Look at that. There you go. Here's the explosive cocktail of things. It's amazing what good of a job vinegar does. These were the really corroded ISA slots, and they are nice and shiny again. Here, this 4069 is, yeah. If vinegar is applied and it still looks like that, then your chip is just not gonna be reusable. But yeah, these other ones, they might be salvageable. They don't seem to have too bad of no problem. Maybe this one I won't reuse because it's already looking very crusty. Now here's the thing, hard to obtain parts like this NEC keyboard controller. I did end up cleaning, even though they looked really terrible. And I think they didn't turn out too bad. Of course, to re-tin everything, then wick it up, and then scratch off the rest of the dirt, which didn't like work 100%, but it's still like a lot better than it was before. And this one I still gotta do. This is the RTC chip. Now I might be able to get this from my local shop, but it's definitely not something I'd like to count on.
Now here, unfortunately, I seem to have lost the recording that shows what happened after I put the thing back together. Now, the board came to life and it actually posted until code 1.3, which is a code that all the old AMI code listings are extremely vague about. But some of the people at TRW have experienced this before and said that this problem is memory related. So that's where I ended up looking. To figure out if the board was principally functional, I followed an advice from Computer Guy 096, which was to run the Landmark AT test ROM, which is a really handy test ROM which tests all sorts of functions of an AT class motherboard, up to around, I would say, Pentium 1 486 sort of era.
Running the Landmark diagnosis thing here, it's showing a memory error, which is cool. So we're getting somewhere. I was noticing on the oscilloscope that the address bus on the RAM sockets was partially floating, and the offending bits are connected to this chip that I had replaced, 74F245. So I will replace this with another chip. Maybe the replacement I had was broken, and then we'll see where we stand. Here's the replacement, 74F245N, that I've desoldered from an ISA video card. And I'll put that where it belongs, right over there. Right, so put the original BIOS back. I'm not gonna bother with the test ROM for this one. Put some RAM in, solder the new buffer chip. Let's see. Well, doesn't detect video cards, but it posts. Right, so I'm making progress here. The Landmark test ROM now completely runs through, so that's no problem. However, it still doesn't detect graphics cards, as we saw. What I also noticed is, on the VGA BIOS ROM, the output enable pin right there is not toggling low, which means that the graphics card doesn't detect cycles, read cycles from its BIOS ROM. So the motherboard BIOS doesn't see the VGA BIOS ROM and thus doesn't detect a VGA card. I found a thing. Okay, so basically I checked all of the signals and they all seemed fine, except I found one that behaves strangely. It's stuck at 5 volts and it's not supposed to. It's the MEMR signal, that signalizes a memory read instead of an IO read. This is on a working board though, and as you can see, it pretty much does things fairly immediately after starting the machine. That's obviously not good. On another board where I have a schematic that has a different chipset, sadly, this signal is connected to the chipset using a 33 ohm resistor, and I will check how that arrangement is done on this board, and hopefully that is the last thing that's broken on this machine, and I can smell the success. And I found something, man. Look at that. That's the MR signal, and that's the via it's supposed to connect to. It is not. Somewhere this trace has a break, it seems. And like, it's not that this via is like, or this pad is messed up, because if I move straight down to another port, you see there's definitely continuity there. But this trace is broken. Okay, so I came up with a fix here. I have a tiny piece of wire that goes through the pad, hopefully leaving enough space for the pin from the actual ISA port
to go through later. Comes out there, connects to the trace. So that should fix the MEMR signal. I'm gonna turn it on. Let's see if we can get something out of this. It would help if you connect the power connector. That would be actually really helpful. Okay, let's go. Oh, oh you! No way, man! Yeah, nice. Victory was mine, but not for long. There's a slight problem left here. Damn, that's a fast clock. Hang on, what does this look like on the scope? Oh. What I'm doing here is probing the RTC real-time clock oscillator, which is usually located either somewhere close to the RTC chip or on later motherboards the south bridge. It's supposed to stably oscillate at a frequency of 32,768 Hertz, which it clearly isn't. Yeah. Oh, that I don't think that's right. Let me go fix that. So I have now replaced the crystal with a new crystal from a donor board. And here's the old one. It was very corroded, in fact, and I don't blame it for failing. Now we should have 32,768 Hertz. Close enough. I'd say that's fixed it. Let's go into the BIOS and see what it says about that. Yeah, that looks fine. It's always a bit hiccupy in this BIOS screen. It's always been like that, but it's not skipping ahead like 2-3 seconds at a time. That's fixed now. I'm going to do a CR2032 mod on it. I'm going to clean up the soldering, and then I will put in my test CF card, and we'll do some benchmarks, and then we'll be done with this. So, slight problem, which is something you can run into with these boards. I did the CR2032 mod here by removing the charging current supply resistor. You can see it there, it's lifted. And I have around 3.2 something volts on this. It's not oscillating at the right speed, so I'm guessing this is one of those boards where that voltage really matters. And for those boards, I do have a supply of new nickel metal hydride batteries, which run at 3.6 volts. And most probably that'll fix the problem. And it is oscillating at the correct frequency. Well, almost, but I mean, that's... I'm going to replace one of the diodes that supplies the actual battery voltage to the RTC, with a Schottky diode that has a low forward voltage drop. And that will probably give us that extra bit of margin that we need for the RTC to stay stable if we have a bit of a drained battery situation going on. Okay, so I replaced the diode, and it looks ugly because it's a really big fat diode, but it's the only one I had with a really low forward voltage drop. It has like 0.1 volts, 0.15 or something. So, okay, so that actually seems to have helped so much to the point where I'm now getting a really nice and stable voltage, oscillation, with a coin cell. So I can keep this mod in place, and all will be well.
Okay, so I'm in the BIOS now, and the first thing I see that kind of bothers me here a little bit. This BIOS is one of the earlier ones that doesn't actually have a hard disk auto detection yet, so I actually have to look in my SD card datasheet, CF card datasheet, user types with 989 cylinders, 16 heads, 63 sectors. Now, theoretically, out of the box, I've got 8 megs installed here for now. Theoretically, out of the box, it should be able to run all the benchmarks I need. Does it detect the cache? Yes, 64 kilobytes cache memory. DOS bench. Landmark speed system test. Yes, yes. Okay. Not sure if that's a good result, but it definitely is a result. This next, I think, benchmark CPU speed. So we are slightly slower than an ordinary 386 DX33. I think we can optimize that a little bit. I think what's holding us back is probably, among other things, the fact that we do not have an FPU installed, which is probably going to be limiting. Oh, actually, according to this, we outperform the DX40 by quite a significant margin, by like 3 pixels even. Maybe even 4. So we've got a memory throughput of 17 megabytes per second. It's slow, it's a 386, I guess we can forgive it. 571 megahertz? Damn, this CPU is more interesting than I thought. So these are certainly some numbers. I guess some tweaking can be done here. I have absolutely no idea. I'll check with my friend Micha tomorrow, and he will probably have a better idea of how these numbers are supposed to be interpreted and what we can tweak with this thing. I have a Sound Blaster 16 CD SCSI or whatever it's called in this machine. Oh dear. Oh, that's not good at all. Let's disable the filter. I think I've given it some headroom. Yeah, seems to be okay. My DX40 board that I tried, it was struggling quite badly with this, and the difference between the two is this one has cache memory, the other one didn't, and it goes to show that the cache memory really goes a long way on the system like this. I must say I'm mildly impressed. Oh no, it's not liking it. No, no, no. Aye, so close yet so far. Can give it. Okay, but how about a 4-channel XM file, because that's a bit more complex for it. Yeah, I shouldn't have tried. Well, that's it for this video. Thanks very much for watching. It's been way too long since I've done something on YouTube, but honestly, the hobbies that I usually show on this channel have taken a bit of a backseat to this. I've been very active in the retro scene. I've been contributing to the retro web a lot. I have the rank of contributor there, which I'm very proud of. I don't contribute nearly as much as I wish I could, but honestly, every time I get a board in that has some info missing, pictures missing, I jump on the opportunity first thing I can. Do check me out on Twitter. The handle is OERG866, where I usually post updates about hauls and repairs that I'm doing. Check out my Twitch channel, which is ClarryOW, ClarrYOW, where I go live once a week or once every 2 weeks, depends on how busy my daily schedule is, and show off cool hardware hauls that I picked up, repairs and other things where I hang out with my friends and we just mess around. So, that's it from my side. Thank you and have a good day.